Our next topic is calculate electric field from electric potential. Means that we have to find the electric field E from electric potential V. To find that, suppose due to a charge we have equipotential surfaces. Potential of this surface suppose is V. This one is have potential V plus dV, and this one has V minus dV. Suppose the point P at this surface and place a charge here, and we also know that an electric force is acting on this charge. Suppose force is in this direction Fe, and due to this force charge is moving toward this side and covers a distance ds. Possible there are some students which are confused how force is acting in this direction and charge is covered distance in this direction. Here we have Fe cos theta in this direction, so that is why charge is moving in this direction, and the angle between them is the theta. As force is acting on a charged particle and it is moving covers distance, means here work is done, which can be given as W equals to Fe dot ds, or Fe equals to Q naught, this charge is Q naught, E gs, and Q equals to E ds cos theta, equation 1. We also know that work done can also be defined in terms of electric potential, which can be given as V equals to minus work done per unit charge. And as the work is very small, means potential is also very small, and from this equation we have dW equals to minus Q naught dV, equation 2. Comparing equation 1 and equation 2, we have Q naught E ds cos theta equals to minus Q naught dV. Q naught will be cancelled and we have E cos theta equals to dV over ds. It means that value of dV over ds depends upon the angle between Fe and S, which is theta. And now the value of dV over ds will be maximum if cos theta is equals to 0. And why we are assuming it maximum, here we will see why. But now for maximum, E cos theta maximum equals to minus dV over ds equals to maximum, and cos theta maximum equals to 1, so here we will take E equals to minus dV over ds maximum, equation 1. Now why we take it maximum? Because maximum rate of change of electric potential with respect to position in any direction can be given as potential gradient, means that dV over ds equals to gradient of V. In other words, dV over ds equals to gradient V del V, or partial over partial xi plus partial over partial yj plus partial over partial z k into V. But say equation 2. By putting the value of equation 2 in equation 1, we have E equals to minus partial over partial x by multiplying V I plus partial V over partial yj plus partial V over partial zk. And we also know that E is a vector quantity, which means that it also has a components can be given as exi plus eyj plus ezk. Comparing on both sides, we have ex equals to minus partial v over partial x, ey equals to minus partial v over partial y, and ez equals to minus partial v over partial z. So in this way we can find the electric field Ex, Ey, Ez, which means in any direction from electric potential.